So thank you everyone for joining. Really excited to kick off the first session of Smarter Sessions, and really excited to have Xander and Jamie kick this off with their CalCoupa presentation. Really excited to kind of see it live, and I think you all will find a lot of value out of it as well. So with that being said, I will go ahead and hand it off to them.
All right, good morning. My name is Xander Stein, if anyone hasn't met me yet, and I'm here with Jamie. Let me see if I can find the button to start presenting. My goodness. I'm gonna do it this way. Okay. All right, so Jamie and I today are going to talk about enhancing compliance, sustainability, and your bottom line with artificial intelligence. Let me see if I can hide this warning and get myself situated. All right. First, a little bit about us. My name is Xander Stein. I am a chemist or was a chemist, and now I'm a regulatory compliance expert. I do a little programming, a little AI wrangling, and when I'm not at work, I love to be outside, hiking, biking, skiing, playing games too.
Good morning, everybody. My name is Jamie McDonald. I am the self-proclaimed and sometimes otherwise proclaimed waste expert. I've been with Republic Services for 25 years, and obviously in the industry for that long as well. And I oversee all of our retail compliance programs for all of our retailers. So the teams who support our retail customers on a day-to-day basis are all on my team. So it's a pretty fun job, always something new. And I'm really excited to talk with you guys about the programs that we offer. So I think the critical component of this slide is that Republic and SmarterX really partner together to provide not only a complete set of recycling and waste services, but also give you the ability to manage your regulatory compliance at scale. Things that used to take a very long time and a lot of effort from individual team members and waste experts, parsing through data by reading through it. We're working together to provide a technology that allows you to not only do that at scale, but trust the data that comes back to you.
So we're hoping to show you a lot more information that will give you the lay of the land there.
So a little bit about what we're actively doing together. Connected Pickup is our biggest initiative that we're working on together. And this is a technology that allows us to see waste volumes before we put a truck on the road. A lot of scheduling around retail compliance program is based on historical data. We make decisions based on what you did last year or the year before and what the volume generation was. Whereas with Connected Pickup, we're able to see your volumes as they're being generated and make a decision perhaps 2 weeks before a truck goes on the road to say whether or not that location needs a pickup. You can go ahead to the next bullet. It's a differentiator in the industry. We are the only ones offering this. And generally speaking, it saves retailers about 30%, which translates not only into operational efficiencies, but cost savings. The average retailer saves around $200,000 a year by optimizing their pickups and not paying for stop fees that are unnecessary.
This is just one way that we can leverage the power of data.
And there's Sorty telling us we do get to do really cool stuff together. He's my favorite company mascot of any company I've ever worked with or worked for. So I love seeing when he pops up on the screen. You want me to grab this one, Xander?
Sure.
11 million pounds of diverted waste, 2.5 million pounds of safely treated haz waste, 1 million pounds of recycled product, and 8.3 million pounds of donated consumer goods. This is the backing that you're getting when you partner with Smarter and Republic. We use technology to help make informed decisions so that those waste, that 11 million pounds of product, can get diverted and doesn't have to end up in a landfill.
All right, so that's our little intro for the rest of this presentation. Our goal is to illustrate how technology can simplify your operations, reduce your risk, streamline your sustainability and compliance work. We can use this to minimize your generator status, waste generator status, and maximize your agility in the workplace. So we're just going to show you a little bit about how you can add AI into your strategy in your day-to-day. First, this one's Jamie's.
A quick poll. Raise your hand if you've Googled something. If you're not on camera, you can use the little raise your hand feature. Googled something today or this week. So, right, lots of you have Googled something. We all use Google to ask questions. The good news is you're already using AI, and Xander's going to tell you a little bit more about what that means.
So a Google search is a type of embedding search, which means that Google has a list of all the web pages and sort of all the data that's in there, and they've created a map, a knowledge map of the internet. And when you put your search in, they're finding the most semantically related parts of the web that are related to your search. So this is a type of embedding search. That's why, if you search for pet-friendly restaurant, you find a dog-friendly bar. There's not a lot of identical letters in dog-friendly bar versus pet-friendly restaurant, but you do, but the meanings are the same or similar. So that's an example of an AI-powered search technology, right? We're finding we're gaining access to the meat and potatoes of what the meanings are of words or things or products. We're also going to
introduce you to Barb now. She is our compliance officer for a retailer. She has to make decisions, really complicated decisions every day about transportation, storage, and disposition of waste to protect the company's reputation and their bottom line. And traditionally, her most regulated product is nail polish. She's really good at finding nail polish. That nail polish in particular is carrying a D1 because it's ignitable and a D7 because it is toxic due to the chrome oxide that's in there. Green pigments generally have some type of chromium in them. And her catalog is expanding to stay competitive. A lot of retail stores are carrying things that haven't historically been on their shelves. That's a pesticidal product. The retailer needs a license to sell that in certain states, and it needs to be registered in every state where it's sold. This jacket contains lithium batteries. It's also water repellent, so it has PFAS in it. That's a concern for retailers. Do you want to put that product on your shelf? And if you do, how do you properly dispose of it? Pet meds are another huge issue for retailers. A lot of retailers tend to take a more conservative approach to how they classify pet meds. So they classify them as toxic to be on the safe side, when really a very large portion of those pet meds could be managed as non-hazardous materials.
So just being familiar with all the different product categories, all the different regulations that apply to each of these categories is becoming an impossible task. And Barb's catalog data is a mess. Here's a map that we created, an embedding map of the universe of products for a certain retailer. You can see that the products are grouped by their category. So maybe you can't see because it's a bit of an eye chart, but we've got women's technology in the top left. We've got workwear up here. Similar products are grouped together, and this is sort of how a human might think about their catalog, right? Oh, my cosmetics are over here, and my nail polish is this subset of those products. That's regulated. I have to care about these, but over here I've got my battery-powered equipment, and whenever there's a lithium-ion or lithium metal battery, I have concerns related to transport and disposal. So we're just taking a look at what Barb can find and all the risky regulated products she can't. Additionally, Barb is surrounded by regulatory change. New regulations affect an entire inventory. They affect existing products, new products. Some regulated items may not have ever been classified before. We see increasing rate of change from global transport regulations, battery regulations, PFAS regulations, additional rules targeting particular ingredients. We see a lot of states all of a sudden targeting food ingredients like food dyes and preservatives that are in proposed restrictions in, I want to say something like 30 states. There's new chemical bans under the TSCA program. There's a cacophony of extended producer responsibility programs for packaging, electronics, hazardous products, batteries. So we have a little chart here that came from ANHISA that shows a 35% growth in regulations every 4 years.
And just to add another note, this sounds complicated and overwhelming because it is, right? Having an associate on your team who understands all of these factors, that's a very valuable person. And a lot of companies don't have the ability to hire someone that understands regulatory compliance at this level, or they have one person who's trying to manage a program for 1,000 locations. That's really complicated.
In addition, we have a little bit of a deregulatory trend on the federal level, and this actually creates more changes and less alignment because US states are expanding their regulatory actions to compensate. So we see inexperienced state regulators taking the reins from more experienced federal regulators. We see state legislatures creating new obligations for their agencies to make new rules and then failing to meet their deadlines. So a little bit of chaos there. We see acts that impose duties that look like a regulation, right? States using the legislature to directly regulate an industry. That happened with the New York dioxane ban. The thresholds were set right in the act itself. So even though there's some reduction in regulatory burdens, that we see executive orders targeting certain types of actions, we see more action from the state. And then a lot of these states are scoring political points by enacting these new rules and looking to counterbalance a more limited federal authority. So all that to say that Barb is in a pickle.
Her catalog's expanding, but her funding certainly isn't. The regulatory environment is becoming more and more complex, as is her catalog. And overclassification incurs a lot of unnecessary cost and really environmental impact. And scaling manually to categorize products, it really isn't an option. The amount of time that it would take to parse this level of data is astronomical. I know that sounds a little dramatic, but when you think about the size of your catalog, your product catalog, it really is. This is an example of a letter that a generator had to write to the EPA to ask for an extension on storage limits. The reason is last year and this year, incinerators were so over capacity because of overclassification that they couldn't manage the volume that was coming into their facilities. So making appropriate classification decisions doesn't just impact cost, it also impacts your ability to dispose of materials.
That's where the AI comes in. So we're going to show you how Barb can adopt modern tools to solve her modern problems. AI creates living, breathing data. Any product can be classified with just the UPC and the name. I've got a little chart here of a sort of schema of how to approach a product classification. This relies on a deep well of product knowledge, right? Expert curated data is the basis of facts that we're using for this. And AI can function sort of like a team of experts. So I described how an embedding search or an embedding model is a lot like a human mind, sort of thinking about how products are categorized and how they're similar or how they are different. Our models can access and combine that type of data and rely on it or leverage it to classify a new product, see how it fits into the existing universe of classified products. It can perform reasoning on products and their attributes. It can perform product data normalization, and then arrive at a compliance decision, really using that living database and iterative process. So everyone on the call is probably familiar with this. This is how a human being performs product classification, item handling. The first thing that you do when you want to classify a product is you collect your basis of facts. So maybe you're looking at the label of a product to find the ingredients, hazard classifications, warnings. There's a UPC on there. There's a description of what the intended use is on that product label. And collecting product data really includes reading documents and labels, searching online. If it's a cleaning product, there's cleaning product right to know information. It's mandatory posted on a website. You can also see it kind of in this section of the label here, which you can't read. So once you've collected data about the product, that's sufficient to classify. The next step would be to classify it, right? So you perform classification, you look at the product data. Are there any ingredients that are environmentally hazardous? Are there any, is there a sign that the flash point might be below 140 degrees and cause it to be ignitable? Lastly, the classifications guide business decisions, right? So if you have a flammable product or a corrosive product and it's been returned and it's time for disposal, your operations have to put that into the red bucket or the blue bucket or whatever instead of the garbage. So what we're going to show you is how AI can take over or assist with these steps. The first step there was collecting data. So but just focusing your efforts onto your category of interest. What we found is when we look at a retailer's product catalog, maybe 90% of the products aren't regulated. Their t-shirts, their tiles, their rake, and those products aren't posing a serious regulatory risk, either for transport or disposal. And being able to scale that type of review on a catalog with millions of products is a major feature. This is not a one-time task. When a new regulation comes out that affects only the CFL bulbs or only the products that have a button cell battery, being able to go back to that catalog and generate new insights on the same product catalog is something that traditionally would take months of human effort and now can be performed nearly instantly. So, find the formulated, find the fluorescent bulbs, find the batteries.
I compare this to, I don't know if y'all have seen X-Men, but when Professor X goes into his little helmet thing and is trying to find certain mutants and certain people, this is literally what this technology is able to do. And I know it sounds a little bit silly, but what Xander just described is finding a very specific thing in a very broad grouping of items. It's the needle in a haystack. And this system allows you to do that very quickly and very effectively with a lot of trust in the modeling, because it's not just built on a whole bunch of products that are hanging out there in the universe. It's built based on almost 10 years of data compilation specifically in this space that Smarter has been working on. So there's a lot of validation through this process as well, which is something that's very important to me as an agent of a TSDF, a disposal outlet. Our approvals teams trust this data modeling because of the validation process that happens.
Another feature that we've developed is the ability to collect and verify key data from publicly available sources. If there is a safety data sheet for your product, you can close the data gap, find the toxic ingredients, identify not just what are the hazards, but what are the ingredients that lead to those hazards, what's the transport attributes of this product. Here's an example of a safety data sheet for a motor oil, and it had 2 ingredients in section 3, but a bunch of additional ingredients mentioned in section 15. The human analyst isn't necessarily going to find all this information. And when they do, it's hard to normalize, right? I see benzene. What's the CAS number for that? Are there other names for these substances that we might recognize more readily? This is all the type of information that can be normalized and turned into sort of a more usable data set using AI. So just normalizing data or turning it into, a column on a spreadsheet that a human can analyze more quickly. We're also doing that not just with an SDS, but any sort of document. We can find the battery presence, we can find the chemistry of a product, we can find Prop 65 status, the type of refrigerant, light bulb type, the screen size. So we're gathering this data at scale by questioning documents. On the right, I have a manual from, this is actually highlighted by one of our customers, where the manual talks about a remote that is rechargeable. And typically a rechargeable battery is going to be lithium ion. So that means this entire TV is potentially regulated for transport and disposal. The last sort of way that AI can help gather data is really leveraging modern data sources. So tapping into the internet, we know that suppliers have a wealth of information. They've published that to sell the product, right? If we're advertising a waterproof jacket or a stain-proof sofa, we've got some information about the chemical substances that might be used in that product. Searching is a really common activity for compliance professionals. We're doing that a lot to understand, what is this product made of? What is the likelihood of a battery? How does it work? And we can use AI to perform what's called grounded search. So this is do a search and then take all the results that have relevant information and again, normalize that into simple factors, right? Battery, 99% likely. So that's data collection. Now for classification, we can also automatically apply judgment under any regulation or scheme. So this is using a rules prompt or a large language model that can apply rules written in a natural language. Because the regulatory requirements are changing, we need these rules to be flexible and meet the evolving need. These are predictable and scalable, and they often deliver a reasoning. So just one example, we're evaluating a product catalog and notice that some of the products look like they contain a flammable liquid, but some of them were empty, right? It's an empty fuel can. And so we built this model that sort of has this prompt to apply some rules. And then just using that payload there with an item number, the description kerosene can, our model is able to identify, hey, this is actually an empty can. It's seen every bit of information on the internet. We think it recognized that model number. We know that it knows what a kerosene can is. And it even provides this explanation, right? So if your associate wonders in the back of store, why am I putting this in the regular trash? They can see this explanation. The product is an empty container intended for holding kerosene. And then they can think about that, right? Oh, I feel something sloshing in this container. Maybe it's not empty right now and I should empty it. Another method that we'd like to highlight is model training and embedding search. These are really ways to leverage the 10 years of experience that Jamie mentioned. So creating a map of the products that we have classified to really highlight where a product might have a classification. So on the right, you see a map of, this is a map created on ingredient lists of products with how flammable they are. And you can really see a tight grouping, right? Products that contain ethanol, they're all quite flammable. Products that are mostly water-based, not flammable. And so even if you don't have a flashpoint and your data enrichment isn't able to find one, as long as you have ingredients, you can still classify. Similarly, model training is a method we can use to take a lot of expert tagged data and then both evaluate and train a model to be better. Think of it like training an intern. You bring an intern in, you tell them the regulation, you show them the document so they can read it, and then you do a bunch of examples together. Doing those examples together builds skill in your analyst and also trust in their abilities. And this is what we're able to replicate with AI models. So just summing it all up, SmarterX can apply these capabilities with speed, scale, accuracy, and accountability. We're using a loop to learn and test and refine our models and our prompts. We have we're creating a universal product attribute database. So this is all the public data we've gathered, all the AI insights, as well as the expert curated intelligence for every product. We're able to create these interconnected workflows that combine regulatory information, chemical knowledge, product knowledge, right? Think about suppliers of aerosols that are a bag-on-valve system and call it a non-aerosol. Well, we know that it still meets the definition of an aerosol because there's a compressed gas in there. This also allows us to continuously research and classify products using this sort of scheme here. So the result is 100% regulated item classification for your entire catalog that always answers the question why. We're not waiting for suppliers to register and provide incorrect details. We're finding those details automatically. By automating data enrichment and classification, Barb can finally run and audit her robust compliance program. She can answer questions from her store associates. She's got time to interface with her bosses and with her colleagues and her stakeholders. This AI normalization can point you to its sources, helping the human to quality control and review products where there is a question or there might be a need to call, right? If the data isn't available, there's certainly times that you need to call the supplier and talk to them about it. And that's where AI can help you identify that need. And then the procedure produces a result with an explanation to understand why the product is hazardous or not. And regulators look for these explanations during an enforcement action. Jamie's got to go soon.
Yeah, I'm going to hop off right now, actually. But you guys are all in great hands with Xander. So thank you so much. We'll talk soon.
Thanks, Jamie. All right, so just wrapping up, I wanted to show a few examples of tricky products and items that might be of interest. So just a quick exercise, think to yourself, which of these products would be a hazardous waste? So on the left, you have two hand sanitizer products, and on the right, you have two nail polish products. If you were just basing this off the category, or you had very little information about these products, you might presume that all of these products are ignitable waste, D001, because of the presence of ethanol in hand sanitizers and flammable solvents in nail polish. But the fact is that two of these products are not ignitable waste because they're water-based. So the sanitizer on the left is actually used as an ammonium compound, quaternary ammonium compound, to do the sanitizing, and the entire brand Piggy Paint is water-based nail polish. So just looking at the ingredients and doing some data enrichment allows a compliance professional to more accurately classify these products than they otherwise would. If you're using a back of store chart, you might think all the sanitizers are ignitable. And then this also allows insights to go across the product line. So by brand, Piggy Paint as a whole is not ignitable. And so if our model sees 40 Piggy Paints that are not ignitable because it sees the water in the ingredients, then a 41st Piggy Paint, we can quickly classify with accuracy. We'd have a high confidence on that. So Barb's associates have these clear directions on what's hazardous when it's waste. They have these clear directions for handling returns, which reduces the risk of errors, reduces the time spent on returns and dealing with them, and then allows returns to go back to the supplier faster. We've seen retailers who get stuck with items in the back of the store and they're not able to capture the value of their returns. On the right, I've got a picture of a bunch of, these are lotion products, which are hazardous in the state of California because test data may not be available on their aquatic toxicity, but in other states, they're not hazardous, most states. So those products could be disposed more affordably outside of the state of California, and then the efforts are really targeted on complying where the products are regulated. Barb also has accurate waste classifications for her whole product catalog, So it's critical to properly dispose of hazardous waste. Nobody wants to fail to comply with a rule like that, but it's expensive and impactful to do that. Incineration is associated with CO2 emissions, and so accurate classifications are the key. So we've just solved Barb's waste problem, but what about storage, transportation, restricted chemicals, other sorts of initiatives? We can do all that too. So the same data that we've gathered informs those programs. The data you need to comply is the data you need to really spread your wings and institute whatever program you like. And the classification procedures work on more than just waste classification. So how can you use AI today or tomorrow? Contact us if you're not already in contact with us. Thanks for listening. I would love to answer questions. I have a bunch more examples that we could work through. Any thoughts or comments at this point?
Thank you so much, Xander. I'll ask a question. So if, I'm not super familiar with LLMs. I'd love to know kind of, you mentioned that the rules are written in a natural language. I'd love to kind of have you walk me through that and what that means.
So the art of writing a prompt for a LLM is a good mix of science and I'll call it literature. One key that we found is really trying a prompt out and seeing where it might not get the answer right and then iterating on that. So it's a very iterative process that requires expert tagged data, right? If you want to make a model that finds the tent dress in a collection of dresses, looking at pictures, you've got to have some scoring mechanism so you can tell how well it worked and then tune the model based on that. Let me see if I have an example slide about this. Not specifically for training a model. We can talk a little bit about PFAS. So the bunch of states have written bans on PFAS in products, and it's genuinely hard to tell when a retailer is selling PFAS. And so one thing that we found is so we create a model that says, like, tell me whether this product has PFAS or not, and then we'll feed it information. And one thing that we noticed initially was if a product has a no PFAS claim on it, our model was really believing those, even when the claim was a little bit misleading. So you can have a frying pan that doesn't have any PFOA in it, but it still has a Teflon coating because that can be made without PFOA. And so we'll see products that are advertised as sort of, free of PFOA. And so a model has to be, or a prompt has to be shored up against that type of error, right? So what we were able to do is give it a list of the PFAS-free certifications that are meaningful, and then it can use that information to more accurately review these PFAS claims. Definitely open to questions here, as well as comments. Maybe I can turn it over to AJ to show us some AI-powered tools. Just a little demo time.
Sure. As long as there's no questions. Once, twice, 2 times. Okay. I think I've met most of you either virtually or in person or through a phone, but nice to see you all again. AJ, I'm one of the regulatory nerds at SmarterX. Yeah, I can steal the screen from you, Xander. Let's see here. I will preface by saying I am, what I'm going to show you is more proof of concept tooling, which is using the underlying data, which is the really powerful thing. So you may see different UIs or different framings of information here. And that's really just for the benefit of demonstrating the technology rather than this is actually the user experience. So just keep that in the back of your mind. So I'm going to start with something called the enrichment service, which is kind of incredible, to be honest. What we do is we take some information as little as a UPC and we go through our enrichment pipeline. And so I threw in a UPC here, which I just happened to have up on another screen for some reason. And I'm just going to tease you with the information that comes out of here. So, okay, we've got UPC. What enrichment is doing is it's saying, I took your UPC, I'm going to give you product name, brand, here's a description, here's images and an ingredients list. And now you can see this visually as well as know that this is stored in a JSON format. So like, oh, this could easily be transferred through a data exchange if that's what you wanted. And so what I wanted to show is just take like one extra product, so you can actually see it doing the work here. So I'm gonna take a UPC here, which is a Q-Tex nail polish remover pad. We're gonna hit search. And you're going to kind of get a view of, again, this is our internal tool of what enrichment looks like, but enrichment's in progress. It's computing. I'm just going to give this a second here to do its thing. Okay. And so you think about all the data that it was showing previously, and now it's basically doing that in real time at this moment for this particular UPC. Okay, and look at that. We've got our product name here, the brand, a nice description, product images, and an ingredients list. So this is the power of enrichment, and this is really what sets us up for success in the classification world. So actually, before I go on, I just want to say, if you have a UPC that you want to like throw in here live, which is always more fun, please put it in the chat. It may or may not be successful, but why not try it? So if you have a UPC that you want to throw in here, we'll come back to it, put it in the chat. And what I wanted to do was, okay, so we have all this information. If we take this UPC, and I wanted to show you, again, this is a kind of a separate UI, but once you have your enrichment done, and we wanted to move on to a classification step, I'm going to throw this UPC in here. I'm going to hit submit. And you can see that it's been updated. It's got the Q-Tex nail polish remover. We've got taxonomy in here. And if you were to go back and forth, you can see that the description here, discover the nail polish remover for you. Q-Tex ultra powerful nail polish. Okay, discover the description is the same. So enrichment, when I go to the classification step, enrichment is really being taken directly. This data is taken directly from the enrichment process. And you may remember down here, we got an ingredients list. And so one of the key classifiers that we'll run is an ingredients-based embeddings classifier. So we've got ingredients down here. If I go to just my separate tab just for ingredients list, you see we've got acetone, water, benzyl salicylate, and a bunch of other, some fragrance in here and a few other items. So now I want to show you core hazard classification. This is just one step in the classification process we're doing, but it's taking this ingredients list, and imagine this ingredients list is a fingerprint. And if you think about a giant map like you've seen before, this ingredients list is fingerprinted onto a map. And we've said, tell me the nearest neighbors that are like this fingerprint and what is their hazard classification. And so that's what you're seeing down here is it's a hazard class 3, and I have a 92.6% similarity score. Now this similarity score is, I believe it's called like a leucine cosine similarity index, something very techy. But you can see like it's acknowledging that this is acetone based, it's flammable, and its similarity is 92.6% match, like a fingerprint match with another ingredients list we've had, which is also saying it's flammable. So this is just one aspect of our classification, what's running in the background. Does anyone put anything in the chat that they want to run? Akriti, thank you. So if we go back to our enrichment, and again, this is, honestly, it's just cool to see. Okay, enrichment's in progress. Vacation send screen, whip, okay. All right, that was pretty quick. Oh, it's a sunscreen. It looks like something I would put on pancakes. All right, cool. So yeah, we've got our brand name, our product name. We do have an ingredients list here. Oh, and then we have active ingredients. Okay, this is cool because that tells us it's an OTC drug, which makes sense. Anything that's putting out a sunscreen SPF claim is technically a drug, and we'll have a drug fact panel. And of course, we say it's in scope because it's a formulated product. I could take this, go back to our, okay, so now I'm going into the classification land again. Again, we've got the same data being pulled into this classification world, and we've got our ingredients here. There we go. Now, again, let's see what we got here. 96.6% match that it's not regulated. Now, you may think, that sure looks like an aerosol. And so this is where keeping in mind that ingredients-based classification is one element of our classification step. So we're going to be classifying based on, yeah, do not eat, sorry, image assessment. We're going to do other embedding classifiers, and if we have an SDS for that product. So just keep in mind that if you were to look at these ingredients, yeah, you can't actually tell that this is a compressed sunscreen. So when we're looking at just ingredients based, it makes sense that we're getting like, yeah, this is not regulated. So again, it's just keeping in the back of your mind that we're coming at this from many different angles of classification. We're going to look at the ingredients, the product name, the brand name, the other facets that we've pulled in from enrichment, parsed safety data sheet data. I'll throw another one in here. And then Xander, you can keep me on rails here and tell me to stop.
This is great. What a cool tool.
I wish I could take credit for the pretty looking tool. This is, the one that's less pretty is the one I made. So, all right, ortho, weed begun, goes in concentrate. Okay, so again, we got really nice, rich images here. We've got ingredients list for pesticides is actually something really fascinating because they're only required to disclose the active ingredient. So that's going to be much more challenging to use just ingredients lists to perform classification against. But again, we do get a great product name, brand, images. Let me throw another one in here from Gustavo. Nintendo Switch console, is that right? Yeah. Okay, Nintendo Switch console. Again, we're getting like a really rich description here. And these descriptions are incredibly important when we're looking for, does this product come with a whiteboard marker? Does it come with accessories that have batteries? So getting this really rich description data is really critical for getting classification right. We even have here, we're parsing out from grounded search, which something Xander had mentioned earlier, that this operates on a lithium-ion battery and that the watt-hour rating is 15.95. So very cool I love just using this tool and putting things in here to see how well it performs. So far we're getting like 100% hit rate. So if anyone wants to try and throw UPC in here to knock it off, go for it. So yeah, that's one aspect of classification. Like once we get the enrichment data, we can take an ingredients list, for example, and run it through an ingredients list embedding based classifier, which again is just like one of a handful of classifiers that are going to feed into our final decision. I did have one other thing, which I think is just, again, speaks to the level of enrichment and classification and expertise. All right, Kriti, I'll run yours before I go on.
While that's processing, I just wanted to sort of draw a parallel here between what this process is doing and how, like you see it one by one, but this can run on 1,000 or 1,000,000 products as well, just as quickly or faster because it's in parallel. And this is really replacing a process that I used to do a lot as a compliance officer, which is like, what is this thing? I'm looking through my catalog for methylene chloride because it became banned, or for parabens because those are subject to upcoming restrictions or whatever. And just that like catalog review, what is this type of question is so time consuming to answer without using these kind of AI models and grounded search techniques.
Absolutely. I mean, just to echo what you're saying, Xander, it's incredible because after we run these classifications, we are running validation scripts on the backside to say like, does this information check out? Is everything aligned with this record of this product? And there's been times where, again, I'm going through validation and just saying like, okay, let's sample some of these here and see how validation's performing. And it's picking out that, hey, this refrigerator also has a lithium battery. And I'm like, okay, something seems off here. And when you actually get down into the enrichment data and how it's performing it, I was kind of blown away. There's about, there's dozens of products out there that are portable refrigerators that come with, gigantic batteries. And I'm sure no one who sells these is surprised that they exist. But the fact that you can get to the end, have things flagged as this looks like, a funny record. And then you can go back and validate that, this is in fact doing much better than a human would do. A human might say this is a portable refrigerator or this is battery operated, but then to layer these two things on top to get a final classification is pretty amazing. Oh, Erica. All right, one from the audience. Oop. Oh no. All right, we're searching. Enriching.
Using a UPC alone is really cool because you can sort of follow the money, right? If the business requires a UPC to sell a product, inventory it, order it, you can rely on that data to be pretty reliable, unlike maybe a product description, which could have typos or abbreviations in it. And of course, you can use those too, but indexing on the UPC is really powerful for that reason because you can sort of follow the money.
Did I break it? What do we think?
It's, I've got a different tool up and I think maybe it's missing a check digit. Is this
and that could be, yeah, that seems to be the world we live in.
Yeah. So there are things where if you have check digits missing from the end of UPC, or if the UPC is a it's a private UPC, I forget the actual name of them, but you can generate UPCs that are specific just for your organization that are not kind of like public information. It could be one of those as well. Error. I wonder if I can view this. Huh. Okay. Well, the other thing I was going to show was something that's been, I started my career 13 years ago in batteries, so I have a small obsession with batteries. And there is, battery bills coming out in the States all the time. Again, this is just to show you when you are really good at enrichment and you have expertise and AI tooling at your hands, you can do a lot of different things. So this one is, it's called a California Covered Electronic Device Checker. I have a Garmin Venue SQ watch, so of course I'm going to throw that in there. And if anyone's familiar with this bill, it's basically assessing like, would you be required to collect a fee from at the point of sale from a consumer in 2026? And so anyone who's familiar with covered electronic devices in California knows, it's not a video display device because it's not greater than 4 inches. So it's not covered it's not a covered electronic device in California today. You would not see this show up on your receipt. But under the this new SB 1215 bill, this would be considered a battery embedded containing device where you're going to have to collect a fee if you sell one of these at the point of sale. And so all I'd have to do here is type in the name, and you can see, okay, it's not a video display device, but it is a battery containing product. It's non-removable, therefore it's covered. So again, just kind of flexing on this idea of enrichment to classification, which is going to drive action for all of our partners. I did have another one kind of canned in here, but if you have oh, thanks, Xander, I'll check that out here in a sec. If you have and this is where like subject matter expertise and building these tools is really important, because we put in a smart refrigerator here, and we can say like, well, it technically does have a screen, yes, but it's exempt because it's a major appliance with an integrated display. And I'm not doing anything behind the scenes. Like we have rules and structures in place, but it is using a grounded search mechanism to help enrich this product, and then it's running through our rule scheme to arrive at this answer. It's not a battery containing product, and it's exempt from the video display device. Therefore, if you sell a Samsung smart refrigerator, you are not going to have to collect a fee from at the point of sale. Let me switch back to Xander.
Great example, Erica.
There we go.
Our favorite.
Yes, our favorite. I was just gonna
I
say.
have to close my eyes. Okay. Yep. And this is interesting. We're getting in scope no because it's a food item, which it's actually great that you brought this up, because as we're going through our in scope process, one of the things we've been doing is kind of like asking additional questions of the data when we have potential products that are falling in the gap. So we know that food products that also are likely to have hazards associated with them is a gap. And so this is, again, just kind of like a UI version, but in our actual scoper that's performing this, it's going to say like, no, I've captured this because it is a concentrated flavoring agent, which is in scope because it's one of those ones that toes the line. But yeah, we have, a good description, images. I'd be curious to know how this does in our ingredient space classifier. Let's check it out. Mio. Okay, that's all good. Ingredients list. Oh, hazard class 8 with a almost 99% finger match. So this is cool because it is like showcasing that 10 years of collecting and classifying data is like, we've seen this ingredients list before. And again, it's not thinking, it's not saying this, but I'm saying this. We've seen this ingredients list before. This is exactly what a Mio concentrated flavor looks like, and we know that that's corrosive to metals. Therefore, hazard class 8. That's what our ingredients-based classifiers are saying. We're going to have other classifiers running as well, which are going to feed into this. But at the end of the day, this is a very strong signal.
And this is, of course, all designed to sort of give you the most conservative classification. We prefer to return a more severe classification than to miss something which is, you know, is regulated and call it not regulated. So, so obviously that, you know, there's an opportunity here for more evaluation, supplier input, more data to further inform the classification.
Mm-hmm. So I'll stop it, then hand it back to you, Xander, so you can kind of wrap up the session. I think it's at the top of the hour. Is it,
Yes,
we're going
thank
to?
you. Some of this is really just cutting edge search results. You know, if you would compare to a more traditional sort of product review, item setup procedure, sometimes it takes months to gather the type of data that AJ was gathering in seconds there. And so just being able to close the loop and speed to market, I think is the biggest feature that we're really looking to advertise or socialize here. So, you know, stay tuned. We're using these tools today to classify. We are implementing new tools and expanding that range that we're offering, and we're ready to classify millions of products and find the batteries, find the corrosives, find the flammables. So thank you for listening and participating, and we'll see you at the next session.
Thank you so
Thank
much.
you, Xander and AJ.
Ciao.
All right, have a great day.